Assalamualaikum and good day to all. My name is Hazani binti Saribaha with metric number 215279. Today, we are here to discuss and explore the fascinating world of network analysis tool. In our presentation, we will be focusing on four key tools: Ping Plotter, Visual Root, DNS View, and TCP View. These tools play a vital role in understanding and diagnosing network issues and enhancing overall connectivity. So let's dive into this exciting journey of network analysis and discover the power of this tool. Digital world and interconnected realm of informations and communications has revolutionized how we live, work, and interact. However, these rapid advancements bring with it challenges such as cybersecurity threats, data privacy concerns, digital divide, and the impact of automations on employment, requiring constant adaptations and vigilance to navigate this evolving landscape. This research study focuses on analyzing network connections using four key tools: Ping Plotter, Visual Root, DNS Query, and TCP View. The objective is to evaluate the connectivity, latency, packet loss, route analysis, and DNS resolutions during daylight and nighttime, comparing Wi-Fi and personal hotspot connections. Now, let's discuss the scope and area covered in our study. In this analysis, we have focused on two specific websites: eBay, www.ebay.com, and the Faculty of Computer Science and Information Technology, UPM, www.fsktm.upm.edu.my. We have conducted tests using both Wi-Fi and personal hotspot connection to access this Wi-Fi. We also conducted this test in two situations, which is daytime and nighttime. By conducting this study and utilizing this network analysis tool, we expect to gain valuable insight into the performance and behavior of our network connections. We aim to identify a potential network issues such as latency, packet loss, and routing problems, and understanding their impacts on the browsing experience. Ping Plotter is a powerful diagnostic utility with multiple essential features. Initially, it executes a ping test to measure the round trip time between a user device and a target IP address, thereby assisting in the evaluations of network latency. It displays each step along the route and identifies potential bottlenecks or failure points. This feature aids in diagnosing network connectivity problems. Last but not least, Ping Plotter support graphical data representations, making it simpler to interpret and visualize network metrics such as latency, data loss, and jitter. In my network performance analysis using Ping Plotter, I evaluate the connectivity to international website, which is eBay, during the night and day using Wi-Fi. During the day, the test results were impressive, showcasing a mean latency of just 3.2 milliseconds with a minimum latency of 1.1 milliseconds. There was no packet loss, ensuring a smooth data transmissions. The network path consisted of 35 steps, yet only 5 steps were necessary to reach the website, indicating an efficient and reliable connections. Moving on to my nighttime test. The network path for this test comprised 5 fold. Result revealed a minimum latency of 10 milliseconds, an average of latency 21 milliseconds, and a round trip time range from 3.9 to 7.1 milliseconds. Irregular latency spike were observed, peaking at 27 milliseconds. There was no packet loss, indicating a stable connections. Ping Plotter test demonstrated that accessing eBay over Wi-Fi provided stable connection with minimal latency and no packet loss during both day and night. While occasionally latency spikes were noticed during the nighttime test, overall performance remained satisfactory, ensuring a smooth browsing experience. Next, I evaluate the connectivity local website, which is FSKTM, during the day and night using Wi-Fi. During the day, the results show stable connections with relatively low latency, as indicated by a mean latency of 5.3 milliseconds, a minimum latency of 1.5 milliseconds, round-trip latency value range from 17.7 to 121 milliseconds. and no packet loss was observed. The network path consisted of 35 steps, highlighting the complexity of the route. Moving on to the night test. The result revealed a mean latency of 175 milliseconds, a minimum latency of 40 milliseconds, and although no packet loss were observed, irregular latency spikes were noticed, which could potentially impact the browsing experience. To sum up, the ping plotter test demonstrates that accessing FSKTM via Wi-Fi can provide a stable connection with low latency and no packet loss. Lastly, I evaluate the connectivity local website, which is FSKTM, during the day and night using a hotspot connection. During the day test, the result indicated a mean access latency of 68.5 milliseconds, a minimum latency of 26.6 milliseconds. The packet loss rate remained modest, indicating a stable connection. The network path consisted of 11 steps, with latency value ranged from 215 to 2250 milliseconds. While there were variations in latency, the packet loss remained low throughout the test. Moving on to the night test. The test had 2-second interval and a trace count of 30. The initial result revealed a mean latency of 36.9 milliseconds, a minimum latency of 26.3 milliseconds. However, the packet loss rate was unusually high at 55.3%, indicating significant data loss during transmission. The measured jitter value of 60.3 milliseconds reflected a variations in latency. Graphical representation displayed occasional 700 millisecond latency spike. The packet loss percentage remained constantly high throughout the test. The ping plotter test demonstrated that accessing FSKTM via a hotspot connection during the day provides stable connections with a moderate latency and minimal packet loss. However, accessing the website at night through the same hotspot connection revealed a packet loss, irregular latency spike, and high latency, indicating a poor and unreliable connections.
Hello, my name is Al-Halimah Dabalkis in PhD. My metric number is 214822. Now I'll be presenting about Visual Route. Visual Route is a network diagnostic tool which composes several utilities that allows the users to gain complete information related to the connections and visual representations of the path taken by the data packets as they travel through the internet. There are some features that are available in Visual Route. Mainly is traceroute and RTT. Traceroute is very useful to see that graphically all the information is sent through the internet connection of each user, while RTT is the time taken for a request from the network to go from a starting point to a destination and back again in milliseconds. Other features available in Visual Route are in the top analysis area and also lower analysis area, where at the top we have firewall information, network, packet loss data, DNS search time, RTT, route length, and so on. Lastly, at the lower analysis area, we have a display of overall summary commentary for the whole tracer process. Next, I'll show you the data that gained from Wi-Fi to ebay.com.au. I recorded from daylight at 3:33 p.m. and at night at 9:43 p.m. The RTT recorded is 25 milliseconds, while the RTT increased to 34.6 milliseconds. This is probably caused by high traffic level, happens during the night, where more people are known to be accessing the website at this time. The number of hops is at least 15 hops, and after the 12 hops, it responds particularly slow due to the long distance. The packet loss is more at night than at daylight. This is because the event of network congestion, an application may be able to resend those lost data packets. Next, from Wi-Fi to FSKTM website, at daylight, I recorded at 3:39 p.m. and at night at 9:42 p.m. RTT recorded is a small change between 16.1 milliseconds and 17.9 milliseconds. During at night, most people are getting through the website and delay in the network, while at daylight, the network goes faster in response time. The number of hops are similar for both datas, which is 17 hops, and the packet loss is more at night, which is 6.5%, than at daylight in 3.7%. Next is from personal hotspot to FSKTM website. At daylight, I recorded at 3:41 p.m. and at night 9:45 p.m. The RTT recorded, there is a difference only at 190.3 milliseconds and 116.6 milliseconds, indicating that at night, there are more users are getting through the website and experiencing network delays, but at daylight, the network is responding much quicker. Next is the number of hops. At daylight, it's only 18 hops, and at night is 12 hops with an alternate routes. But after the 13 hop, the address responded slowly. And the packet loss is much at daylight, which is 11%, then packet loss at night, which is 4%. Next is the summary. Overall, I can see that the data collected by using Visual Route shows a comparison of each transmission behavior. The RTT value for accessing the FSKTM website using Wi-Fi connection is better than using the personal hotspot because it has lower value on both daylight and night of the RTT value. Moreover, the RTT value on access to ebay.au website is larger than FSKTM website using Wi-Fi connection. In summary, while using Wi-Fi connection, it's best to send and receive packets during non-peak hours, such as daylight, and the results might be varied to which ISP is used throughout the calculation. That's all from me. Thank you.
Thank you, Alhani. Now, I, Noshafika binti Badrazmi, would like to continue this presentation with the DNS data view. Domain name system, or commonly referred to as DNS data view, is a graphical user interface alternative to the built-in NS lookup tool that comes with the Windows operating system. It can be used to view the DNS record displays for one or more domain names. This program has the option to switch to a different DNS server, but by default utilizes the DNS server of the currently active internet connection. A domain name resolution record's time to leave cache time is determined by the DNS server. The TTL value for each DNS record indicates the period of time the resolver will need to get the information in seconds. Firstly, we managed to access the eBay website via Wi-Fi at 10:37 a.m. during the daylight and 11:29 p.m. during the nighttime. Based on the figure shown, the results showed 41 and 62 domains respectively that view their DNS information along with different record types, IP address, and host name in each specific time. Based on the recorded data, line 17, 18, and 20 showed the same error, which is error 9501, that represents a no record found for a given DNS query. The DNS TTL is 172,585 seconds and 172,800 seconds respectively. From daylight to nighttime, the TTL shown decreases. These two frames are used as a medium for TTL updates. Next, all data was recorded and collected at 10:35 a.m. during daylight and 11:11 p.m. during the nighttime using Wi-Fi to access the FSKTM website. According to the figure shown, the results showed 3 and 4 domains respectively that view their DNS information along with different record types but same host name and data in each specific time. Also, we could see that all domains have the same host name and IP address, which are spellha.upm.edu.my and the IP address respectively with a different type of record. The results also showed that the TTL value from both figures increases from daylight to nighttime, that is from 47 seconds to 262 seconds. A longer TTL value represents a less frequent refresh and the information will be cached for a longer period of time. Last but not least, we managed to use a personal hotspot to access the FSKTM website at 10:37 a.m. and 11:27 p.m. According to this figure shown, the results showed 3 and 4 domains respectively that view their DNS information along with different record types but with same host name and data in each specific time. Also, in the recorded data, we could see that all domains have the same host name and IP address, but with a different type of record. However, there was an error of 1460 spotted in figure shown that is during the nighttime, which represents DNS query timeout. The results also showed that the TTL value from both figures decreases from daylight to nighttime, which is from 377 to 334 seconds. A shorter TTL value represents a more frequent refresh, and the information will be cached for a shorter period of time. In summary, DNS Data View is a software that converts a domain name into computer-friendly numeric IP address, which allow users to view DNS record of one or more domain names at once. Table shown is the TTL value recorded for each website in different period of time by DNS Data View. Based on the simplified data recorded by DNS Data View in the table shown above, this clearly shows that TTL value of a record to access FSKTM website is shorter when using Wi-Fi rather than using personal hotspot for both daylight and nighttime. However, the TTL value to access eBay website is way longer compared to the FSKTM website, even though via Wi-Fi connection. Overall, the TTL value increases from daylight to nighttime when using Wi-Fi connection, while decreases during the personal hotspot. Based on the further research, TTL value of less than 300 seconds is considered very short, which makes the most frequent changes for the specific website. In this case, that's all for DNS Data View. Now I would like to pass this presentation to Dwight.
Hello, Professor. My name is Dwight Putad, and my matrix number is 213748. So allow me to present our last tool, TCP. So TCP is commonly known as Transmission Control Protocol, and it's a network monitoring utility that provides real-time information about active TCP connections on a Windows system. And specifically, researchers chose TCP View from Microsoft since it provides detailed information about each connection, including local and remote IP addresses, connection states, port numbers, and the amount of data being sent and received. By utilizing TCP View, network administrators can ensure network stability, security, and optimal performances. But before we dive into network testing, allow me to present to you four major states and their meanings. So one, we have established. It means that the states are in normal for data transfer phase of a connection. Second, we have listening. Represent the state that is waiting for a connection request from a remote TCP application. Thirdly, we have close wait. Shows the endpoint that has received a close request from the remote endpoint. Lastly, we have close. It means that there is no connection state at all. Now, moving on to our first testing from Wi-Fi to international site called ebay.com Australia. I conducted the testing in two modes. One is from morning around 8:35 a.m. and one in evening around 7 p.m. As you can see, the data from the morning suggests that there was a relatively small amount of data exchange between the local machine and the international server during that time period. The modest number of sent and received bytes may indicate that there was less active communication or data transfer occurring between two entities in the morning compared to the other time period. And on the other hand, in the evening, the connection between the local machine and the ebay.com in Australia server remained established, indicating an ongoing and active connection. This substantial increase in both sent and received bytes suggests a higher level of data exchange and communication between the local machine and the server during the evening period. These findings highlight the dynamic nature of network usage. So the higher volume of sent and received bytes suggests a higher level of activity, potentially indicating increased browsing, interaction, or intensive tasks on the ebay.com in Australia website in the evening. So if you're going to ask me what is the best time to order your package, go for the morning. Now, moving on to our second testing from Wi-Fi to our local website called FSKPM website, I conducted two testing, one from morning around 8:42 a.m. and one evening around 7:22 p.m. As you can see, this finding suggests that there was a relatively moderate level of data exchange between the local machine and the local website server during the morning period. Meanwhile, in the evening testing, the connection between the local machine and the local server was in the close wait state, meaning that the local machine had sent a connection termination request and was waiting for a response from the server to complete the closure. This is due to the fact that the local machine sent a higher volume of data compared to the morning, with 6,100 bytes transmitted to the server. Additionally, the local machine received a significantly larger amount of data. This contrasting result suggests a shift in network activity between two time periods, with more active data exchange and potentially more intensive interactions during the evening compared to the morning. And lastly, accessing local website by personal hotspot. As you can see, significant differences in data exchange and network activity between the morning and the evening sessions can be observed. In the morning, the connection state was established, indicating a successful and active connection. However, in the evening, the connection state was listed as close wait, suggesting a termination request. The same reason can be applied where the local machine sent a higher volume of data with 8,209 bytes transmitted and received 1,341,000 bytes of data from the server. So, the implication of this table is that the increase of data transfer and the larger volume of bytes received during the evening indicate higher network usage and potentially more intensive interactions with that website during that time. So in summary, data shows that it is likely to have better transmission of network communication in the morning than the evening. Moreover, the personal hotspot connection involved a greater volume of data transfer in both sent and received bytes, so highlighting potential differences in network usage and activity during nighttime. So, in conclusion, all the network use, such as ping plotter, visual route, DNS query, and TCP view, provides different purposes and insights of a network performance based on the transmissions of packets. Therefore, throughout the project, researchers agreed upon visual route is typically better or ideal for sending packets and analyzing network performances because it gives a comprehensive picture of the network path, monitors ITP, and identifies packet loss along the way. It provides insights into the efficiency and dependability of packet transmission, assisting in the identification of possible bottlenecks and network issues affecting performances. However, each tool shows a distinct purpose which depends on a certain needs and correct additional tools when using ping plotter, DNS query, or TCP view, where it becomes useful for elements of a network research. This concludes our presentation, and here is our references.